Okay, so this is a video on chapter 7 of A2Further Maths. We're taking a wee look at further differentiation and integration. I know it says chapter 1 here, but this is just from old notes. So we're looking at differentiation of sine to the minus 1, cos to the minus 1, and tan to the minus 1. Sometimes it's easier if I write here rather than just have the stuff then to copy across. So what we're going to do is we're going to let y equal sine to minus 1x. So this is just inverse sine, like shift sine you would have hit in third form in your calculator. So we could rearrange that obviously and have x, then gives us sine y. Differentiating here, so normally we have y equals something x, but here we have x equals something y. So we differentiate, we're going to get dx by dy instead of dy by dx, which gives us cos y. Flipping that upside down, then we're going to get dy by dx. So what we're looking for, we're looking to differentiate this with respect to x, is 1 over cos y. But we need to get rid of the y here because we're differentiating with respect to x. So cos y is the same as 1 minus sine squared y. But of course sine squared y here is just going to be our x squared. So we can write that as the square root of 1 minus x squared. So it's quite a strange one here, but you do get used to these because they do appear all the time. Differentiate sine to minus 1x, we end up with 1 over the square root of 1 minus x squared. You may expect to have a sine or a cos in the answer, but we don't in this case. It's similar then for cos. Work your way through. It's minus 1 over 1 minus x squared, and tan as well. If you take a wee look, then it's 1 over 1 plus x squared. If we look over the page, it should also be noted that obviously if you differentiate sine to minus 1, we'll just work it out, 1 over 1 minus x squared. That means if you integrate this, you get sine to the minus 1 for cos. If you integrate this, it's minus cos to minus 1x, and then integrating 1 over 1 plus x squared dx then gives me tan to the minus 1 of x. There is another way of doing it, and you can do it then by implicit differentiation. Let's take a wee look at that method as well. It gives you the same thing obviously. Let's see what I have. So we started again with y equals sine to the minus 1 of x. So we can rewrite that then as sine y equal x. Differentiating both sides then with respect to x. So we're going to be finding d by dx of sine y and d by dx of x. That's going to give us then d by dx of sine y. Sorry, I'm going to leave that line out. Actually, it'll make more sense. We differentiate this with respect to x. Differentiate as if it's a y, so we get cos y and then multiply by dy by dx. And if we differentiate then our x, we're just going to get a 1. So that means our dy by dx is 1 over cos y, and we just then plow on then as normal. If you remember, we change that to the square root of 1 minus sine squared, and that's how we work out then the rest. So that's it there toward the end then of that second page. Hopefully that makes sense.